Derivatives of Newton's forward interpolation formula. We have forward interpolation formula given by f of a plus nh equals f of a plus n delta f of a plus n into n minus 1 upon 2 factorial delta square f of a plus etc. We have a is the leading input value and h is the interval of differencing. Hence a and h will be constant and n will be the variable. We will carry out differentiation with respect to variable n on both sides of equation 1. We have derivative of f of a plus nh with respect to n will give us f dash of a plus nh multiplied to h. When you carry out differentiation on RHS of equation 1 with respect to n, we have derivative of f of a with respect to n will be 0. Derivative of n delta f of a with respect to n will give us delta f of a. We have n into n minus 1 upon 2 factorial can be written as n square minus n upon 2 factorial. This term when differentiated with respect to n will give us 2n minus 1 upon 2 factorial. Delta square f of a is written as it is. We have this term rewritten as n cube minus 3n square plus 2n divided by 3 factorial. When this term is differentiated with respect to n, it becomes 3n square minus 6n plus 2 upon 3 factorial. Thus, we have this coefficient for delta cube f of a. Similarly, you can differentiate this term and find out the coefficient for delta raised to 4 f of a. From this equation, equation 2, we will have f dash of a plus nh equals 1 by h times delta f of a plus 2n minus 1 upon 2 factorial delta square f of a plus 3n square minus 6n plus 2 upon 3 factorial delta cube f of a plus etc. This will be first order derivative of Newton's forward interpolation formula. If you wish to find out second order derivative, we will again differentiate equation 2 with respect to n. We will have f double dash of a plus nh multiplied to h square equals derivative of delta f of a with respect to n will be 0. We will have derivative of 2n minus 1 upon 2 factorial with respect to n will give us 1. Therefore, the second term will be delta square f of a whose coefficient is 1 and derivative of this term will be 6n minus 6 upon 6 which can be written as n minus 1. That is, when you evaluate second order derivative, you will have coefficient of delta cube f of a as n minus 1. Hence, by differentiating both sides of equation 2 with respect to n, we will have h square f double dash of a plus nh equals delta square f of a plus n minus 1 delta cube f of a plus etc. which can be written as f double dash of a equals 1 by h square delta square f of a plus minus 1 delta cube f of a plus etc. by giving n equals 0. Here when you give n equals 0, it becomes f of a. Both sides of this equation are divided by h square and thus 1 by h square appears here. When you give n equals 0, we will have n minus 1 becoming negative 1. If you give n equals 0 in equation 2, you will get h f dash of a equals delta f of a minus 1 by 2 delta square f of a plus 1 by 3 delta cube f of a minus etc. We have 2 by 3 factorial becoming 1 by 3 which appears as the coefficient of delta cube f of a when you give n equals 0 in equation 2. Thus we have h f dash of a equals delta f of a minus delta square f of a upon 2 plus delta cube f of a upon 3 minus etc. Thus we have f dash of a equals 1 by h times delta f of a minus delta square f of a upon 2 plus delta cube f of a upon 3 minus etc. We have written this same equation here. These two equations can be used when we are asked to find first order and second order derivatives of Newton's interpolation formula at the particular point n equals 0 or at the particular situation as a special case n equals 0. If in questions n is not equal to 0, then we will have to depend on equation 2 and this equation to find out f dash of a plus nh and f double dash of a plus nh.